In the previous video, we have seen how to find the squares faster up to 125, right? Now here, in this session, what I'll do is I'll discuss some important and interesting patterns of square, and we also discuss certain properties of squares, okay? So, let's start with the first pattern, or one of the most important property rather than pattern we'll discuss in the end. Let's look at the properties, okay? One of the most important property, and in many exams I have seen questions related to this. So if you know this property, to answer the question, it is going to be a cakewalk for you, okay? In seconds you can answer. So the square numbers will never end in, the first property is square numbers will never end in 2, 3, 7, 8. So obviously squares will end only in 0, 1, 4, 5, 6, 9. Okay, so square numbers will never end in 2, 3, 7, 8. This is not required for you. Just remember 2, 3, 7, 8. Okay, now you get a question like this. Which among the following is a perfect square? Which among the following is a perfect square? Your options: A, 7, 8, 6, 7, 4, 1, 3, 2, 1, 8, 3, 8. Option B, 2, 3, 8, 7, 7, 6, 1, 4, 3, 2, 1, 7. Option C, 1, 7, 2, 8, 3, 3, 4, 20, 1, 2. Option D, 1, 2, 3, 2, 1. Okay, so which among the following is a perfect square? So here ending in 8, so this can't be your perfect square. Ending in 7, this is not possible. Ending in 2, that is not possible. Here I don't want to check this. This is ending in 1, so that is possible. Even I don't want to check it. Okay, I can mark this as the perfect square. If it was 3, this is also not possible. Then I need to look for an answer. None of these. None of the above. Okay, I hope this is clear for all of you. So one important property, square numbers will never end in 2, 3, 7, 8. And we have solved one question, and there is no point in solving hundreds of questions. This kind of repeated questions you can see in various exams, not only in CAT. Okay, you can see in SSC, you can see in IBPS, and at the lower level also. Second property is an interesting property. It's actually a square number. Any square number you take, you can write it as sum of consecutive odd numbers. See, let's take 49. Okay, I need to write it as sum of consecutive odd numbers starting from 1. Okay, so what you need to do is take root of 49. What is that? 7. Now write first 7 consecutive odd numbers: 1 plus, 3 plus, 5 plus, 7 plus, 9 plus, 11 plus 13, right? 7, yeah. Now you add this, what you get is 49. So basically sum of first n odd numbers is actually n square. So sum of first 3 odd numbers, 3 square. Sum of first 4 odd numbers, 4 square. Sum of first 10 odd numbers, 10 square. Sum of first 100 odd numbers, 100 square. Now another point which I want to tell you is, you take any square. Okay, let's take 16. So we have seen you can write a square number as sum of first n consecutive odd numbers. Now, can you write a square number as sum of consecutive numbers? Not necessarily starting from 1. I am just telling you, a square number you need to write as sum of consecutive number. You can write if it is an odd square. See, you take 3 square. What is this? 9. This you can write as 4 plus 5. Consecutive natural number. What do you do? Take half of it. You get 4.5. Keep 4.5 as the average, then write. That's it. You have other way also you can write it, but this is the best way. Now I tell you one of the application of this. Now let's see one more example. 5 square. What is this? 25. You can write it as 12 plus 13. Consecutive natural numbers. What about 7 square? 49. You can write it as 24 plus 25. Other example, 13 square. 169. You can write it as 84 plus 85. Now if you observe it carefully, these numbers here, what you got? 3, 4, 5. What is 3? 3 is from here. And 4 and 5, you are writing 3 square as consecutive natural numbers, right? Now here 5, 12, 13. 5, 12, 13. Then 7, 24, 25. All these are Pythagoras triplets. Let's take 3, 4, 5. Okay. So it's actually 5 square is equal to 4 square plus 3 square. It's Pythagoras triplet. Similarly, 13 square is equal to 12 square plus 5 square. Similarly, 25 square is equal to 24 square plus 7 square. So now What is the application of this? I tell you I have a right angle triangle. Okay, so I'm making an application. So I tell you I have a right angle triangle. One side is 3. Find the other two sides. I'm just giving you one side. I'm not giving you any angle. I told you right angle, so one angle is obviously 90. Then can you find the other two sides? Is it possible? It is possible. What I need to do is 3 square is equal to 9. Write this 9 as 4, 5. Or write this 9 as consecutive natural numbers. So 3, 4, 5 are the sides. So 3 square plus 4 square is equal to 5 square. This is a right angle triangle. So if one side is 3, I can find the other two sides. So if I give you one side is 5, what about the other two sides? What you need to do is 5 square is 25. Write 25 as 12 plus 13. Then these two are the other two sides. Like you can write as 13 square is equal to 12 square plus 5 square. So these three are the Pythagoras triplets. I hope this is clear for all of you. So if I give you 11 as one side, okay, what you need to do? 11 square, that is 121. How will you write? 60 plus 61. So that's it. You got the other two sides. So if I give you 9, same is the method, right? So if you observe in all these cases, I have given you odd numbers. Now let me quickly discuss about the case of even number. Let's suppose one side I am giving you even number. Let's say 8 is one side I am given. I need to find the other two sides of the right angle triangle, right? So what you need to do is take half of it, that is 4. Okay, then take square of it. So what is 4? 4 is half of one side which is given. Then take square of it. So what you get? 16. Now the other two sides, if you ask me, one side will be 16 minus 1 and other side will be 16 plus 1. So what is 16 minus 1? That is 15. What is 16 plus 1? That is 17. So these two are the other two sides with 8. So 8 square plus 15 square is equal to 17 square. I hope this is clear for you. What you have done is, okay, let me take another number. Let me take 10. Take half of it. You get 5. Take square of it. You get 25. Okay, so one side will be 25 minus 1 and the other side will be 25 plus 1. And this will be the hypotenuse. So this is going to be 24. This is going to be 26. So you can write 24 square plus 10 square is equal to 26 square. And we know it, right? We know it. This is 576 plus 100 is equal to 676. I hope this is clear for all of you. So what is the conclusion? Ultimately what we have learned, you have a right angle triangle, you get one side, be it odd number or even number. These are the two possibilities, right? You can find the other two sides. You are not concerned about any angles or anything, right? 5 plus 4. Then these two are the other two sides along with 3. So same method in case of all odd numbers. If I give you an even side, let's say one side is 4. What I'll do, I take half of it. Then I square it, which is equal to 4. Then one side is 4 minus 1. Then 4 plus 1. So what is 4 minus 1? That is 3. And this is 5. And that's what exactly you got here, 3 and 5. Okay, here I have given you this 4 even side, so you got 3 and 5. I hope this is clear for all of you. Now why you are getting it is because you don't want to know all these things. It's actually the relation between all the three sides in a right angle triangle is 2m, m square minus 1 and m square plus 1. Okay, so this is the relation between the three sides, or this is what you mean by Pythagoras triplet. So if I am giving you 2m, that's what any 2n number will be even number. This is anyway even number. So if it is 12, what I told you, so 2m is given, one side is given as 12. What I need is m square minus 1 and m square plus 1. So for that I need m, right? That's why I told you to take half of it. Because 12 is 2m. So m is 6. Then m square is, what you need to find out? 36. Then 36 minus 1 and 36 plus 1. So this is 35 and this is 37. Okay. So what is the Pythagoras triplets? 12 square plus 35 square is equal to 37 square. I hope this is clear for all of you. So any right angle triangle, one side is given, whether it is odd or even, you can find the other two sides without knowing any single angle. So actually we were discussing about sum of consecutive natural numbers, and as the application I have discussed all these things, right? Now one interesting pattern, 1 square is 1, 11 square is 1 2 1, 111 square is 1 2 3 2 1. Okay, now 4 times 1 square, now you can tell me it will go up to 4 and will come back 1 2 3 4 3 2 1. So 5 times 1 will be 1 2 3 4 5 4 3 2 1, right? So here you can see like this, 1 2 3 4 5. So if it is 5 times 1, 1 2 3 4 5 4 3 2 1, go up to 5, come back. So what if 9 times 1, like this, 1 1 1 1 1 1 1 1 1 square, what will happen? It will go up to 9, 1 2 3 4 5 6 7 8 9, then 8 7 6 5 4 3 2 1. That's your answer. The CAT question which came from this is the same as the question, the reverse. The root of 1 2 3 4 5 6 7 8 9 8 7 6 5 4 3 2 1. The root of it. What's your answer? 1 1 1 1 1 1 1 1 1, because square of this is actually this. So if I ask you 1 2 3 4 5 6 7, then reverse, the answer is 7 times 1 square. So 1 2 3 4 5 6, then reverse means 6 times 1 square. Okay, another pattern. See, 7 square we all know that is 49, right? Now 67 square, also I have given you the method. So one interesting pattern which I need to tell you is, just write this 49, okay, in between 48. You know this, okay? These two you know. These two you know. So this 49 and this 48 you keep in your mind, rather than 48 4 and 8. Okay, now let me see what is 677 square. Let's write this 49, that is 7 square. Okay, now here 1 6, so you have 1 4 1 8, so 2 6, so write 2 4 2 8. Now if I ask you 3 times 6 7 square, you will directly tell me the answer, right? So first you will write 49, then what you do, 3 times 6 means 3 times 4 3 times 8. Okay, so 4 times 6 7 square will be, first you will write 49, then since 4 times 6 you will write 4 4 4 8. So now it is very simple. If I give you 6 times 6 6 times 6 7 square, how will you find the answer? First you need to write 7 square, that is 49, then 6 times 6, that means 6 times 4 and 6 times 8 I need to write, right? 1 2 3 4 5 6 and 1 2 3 4 5 6. So this is your answer. I hope this is clear for you. Very interesting, right? Now how they ask you question, let me give you a question. So 4 4 4 4 4 4 4 4, okay, 8 times 4, right? Let me write 8 times 8, 8 8 8 8 8 8 8 8, then 49. Now you need to find root of it. So which among the following is the square root of this number? It's going to be a very tough question, right? But if you observe this is 49, then if you see that these are 4s and these are 9, your answer will be 7. And how many times 4 is there? That many times 6. So 1 2 3 4 5 6. This is your answer. If you square this, you will get this. I hope this is clear for you, right? Very interesting pattern. Now another questions that I have seen from this pattern is actually like 11 square is 121. Now 3 times 1 square, 4 times 1 square, 5 times 1 square, etc. we have discussed. Another pattern is you keep on adding zeros in between. Okay, so it's like this. So 11 square you know, 111 square you know, 1 2 3 2 1, 1 1 1 1 square you know, 1 2 3 4 3 2 1, right? This you know. Now let me give you a different pattern. 11 square is 121. Okay, now I'm adding a 0 in between, 101 square. So what will happen is you need to add 0 in between. So you have 1 2 1, you add 0 here, you add 0 here. Okay, so if you have 1 0, you add 1 0. So 1001 square. Then you consider this as 11. So write 1 2 1, then 2 zeros. So add 2 0 here, 2 0 here. So what about 130 square? You write 121, then 30 means write 30 here, 30 here. So one question which I have seen is, there's a question. You need to find root of 1, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Then 2, then 7 zeros. See, this is how you make the question. I have discussed you the concept and this is a question. This is a question which is asked, so, but this is the way you make question, right? So 7 zeros you can see here. So what is your answer? 1 to 1, obviously 1 and 1. 7 zeros means you write 7 zeros. 1, 2, 3, 4, 5, 6, 7. This is your answer. Now how will you make a question? You can just write a question by writing 1 to 1. Write 5 zeros. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. And ask the students to find the square root of it, right? So what is your answer? 1, then 5 zeros, then 1. This is the answer. Okay? So I hope this pattern is clear, and extension of this pattern, adding 0 is clear. Now let's mix both of these patterns, okay? So here you are keep on adding ones. Here you keep on, see, 11 you are keeping, right? This 11 and this 11 is same, and in between you are adding ones in this case and zeros in this case. Now let's keep 11 and we'll keep on adding 0 and 1 both, okay? Let's see that pattern. So you have 11 square, 121. Now 101 square, you know, 102, 01. Now what I'm going to do is, let's add 0, 1 together. 1, 0, 1, 0, 1 square. Okay, see what will happen is, since there is 3 ones, it will go up to 3. That's what you have seen here, and will come back to 1, right? But in between you can see zeros, so put zeros in between. So write 1, 2, 3, 2, 1 as we have discussed, and since there are zeros here, put 0, 0, 0, 0. I hope this is clear, right? Now if 1, 0, 1, 0, 1, 0, 1, then what is your answer? So 4 times 1, so you know it will go up to 4. 1, 2, 3, 4, 3, 2, 1. What I need to do is, in between keep on adding zeros. Now the question which I have seen is 6 times 0, so it will be like this, or 6 times 1 and in between zeros. So 1, the question was this, you need to find root of 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Okay, so in between they are putting zeros, so you are getting a big number. So you observe the pattern, it is mix of both. What is your answer? 6 times 6 is there, so you need to write 6 ones, right? So 1, 1, 1, 1, 1, 1. And easy method is put zeros in between. This is your answer. So if you want to make a question, what you will do? You can ask the students to find the square of, right? 1, 2, 3, 4, 5, then 4, 3, 2, 1. Put zeros in between. You made a very, very relevant question. What is your answer? Right, see this is 5, so write 5 ones. 1, 2, 3, 4, 5. Put zeros. This is the answer. Very confusing but very interesting, right? But this is the way they make the questions. Now without pattern you cannot find this answer manually. There is a pattern, and that's the reason why they are asking this question. Now next interesting pattern which I have seen is, actually the question looks very difficult. Let me give you a question, okay? 1798 square and 1799 square. Okay, so I have given you these two numbers, and I'll ask you a question. How many natural numbers are there between this? See, if I ask you between 1798 and 1799, there is no natural number, right? What I'm asking is 1798 square and 1799 square, how many natural numbers are there? This is going to be very, very difficult question. The reason is, you need to find what is 1798 square. You need to find 1799 square. That itself is difficult because you need to do the multiplication if you are not using the shortcut which I taught you. Okay, and after, that's not the end, right? After that you need to see the difference, and then you need to see how many numbers are there between these two, right? But now onwards you should not do this. I give you the method. The answer for this question is always twice of this. 1798 into 2. So 1798 into 2. That's your answer. Now you don't want to multiply 1798, take it as 1800. So you know 3600 is the twice, right? Now subtract 4 because this is 8. So 3596 is your answer. I hope this is understood, right? Now, I have never prepared for this question. I have never seen this same question. I just made a random number. I just took a random number, made a question and got the answer here only. I did not do anything or any homework for this particular question. See, what I did is, I gave you a question. I gave you two numbers. I can give you 27941, okay, and 27942. How many natural numbers are there between the squares of this? What is your answer? This number, you take twice of it, you get the answer. So you can do the calculation. If you want, just multiplying by 2, take twice of it, right? So your answer is, so here 2, 8, 8, 5 and 5. So this is your answer. This many natural numbers are there. So the reason, now if you ask me why, let's see, 3 square and 4 square. Let's take simple number and understand, okay? Now onwards, you don't want to know the reason. You don't want to know all these things, right? You just got the answer, okay? So take twice of it, that's your answer. So 6. Now why you are getting 6 if you want? 3 square is 9. 4 square is 16. Now if you see how many numbers are there between 10, 11, 12, 13, 14, 15. Now if you count this, how many is there? 6. And that's the question. So 3 square, 4 square, 6 numbers are there. How are you getting this? Just take 2 times this 3. So if I ask you 10 square and 11 square, between them how many numbers are there? Just take twice of this. So 20 is your answer. Now why 20? Because 10 square is 100 and 11 square is 121. Now since these are smaller numbers, you can find the square and you can write 20 numbers are there between 1012 120. But when it comes to bigger number 98761 and 98762, how many numbers are there between? Now this is going to be difficult for you. It's not worth finding square of it. Finding square of it, what you do? 98761, 98761 you need to multiply. Finding square of this 98762, 98762 you multiply, you get the square, and that's not the end. You need to take the difference. But what is the method which I told you? Just multiply by 2. You get the answer. Now if you generalize, it's like this. You have a number n and you have a number n plus 1. So these two are consecutive numbers. So the squares, how many natural numbers are between these squares? Answer is always 2n. Answer is always 2n. So between n square and n plus 1 square, there will be 2n natural numbers. If you need to generalize or if you need to have a formula. Otherwise, just keep in mind like this. I hope this is clear for all of you. Okay, so this is one of the question which I have seen. So any question now, like 321 square and 322 square, between them how many numbers are there? Twice of this. So 321 twice means 642. So 642 natural numbers are there between the squares of this. Clear na? Now let's look at one more question which I have seen in SSC earlier. 1 square plus 2 square plus 2 square is equal to 3 square. This is a pattern, okay? So 1 square plus 2 square plus 2 square. See, this 2 square is actually, this 2 is actually 1 into 2. This 2 is actually 1 into 2, okay? So answer is, this is 2, so next number, 3. Now if you write here, 2 square plus 3 square, what will be here? Product of this. So if 6 square is coming, the answer will be next number of 6 square, that is 7 square. Or next number of 6 and square of it, 7 square. So I hope you understood the pattern. So you can tell me now, if this is 3 square plus 4 square plus, okay, product of this, if this is 12 square, what will be this? Your answer is next number, 13 square. So this is one question, right? Now, if I want to make, I make a question like this, 4 square plus 5 square plus dash is equal to 21 square. So the answer is direct, right? 4 into 5, that is 20. If this is 20 square, then only this right hand side become 21 square. This is a pattern. Now if I write 5 square plus 6 square plus this product 30 square is what? If I give you a question like this, you don't want to add all this, you can just write this as 31 square, next number of this. Or the reverse will be, now I can give you any questions, right? See, instead of, I can keep the 5 unknown and write dash plus 6 square plus 30 square is equal to 31 square. So what you need to see here is, this is 30, this is the next number 31. So this 30 must be product of this two. So it has to be 5. Okay. Similarly, same way, I can hide a 6 like this. 5 square plus dash plus 30 square is equal to 31 square. So you see these two are consecutive numbers. So if this is 30, the product of this has to be 30, right? So this has to be 6 square. Now you can tell me if I am taking 6 square plus 7 square. Now you can tell me what should come here, right? If this is plus, this has to be the product. 42 square should be equal to 43 square. Now I can make any question based on this pattern. I hope this is clear for all of you. Now one more interesting pattern which I need to tell you is, let's take two consecutive squares. Okay, let's take 41 square and 42 or 40 square. 40 square and 41 square. Let's take the difference between this, that is 41 square minus 40 square. So what I told you is two consecutive square numbers, the difference. Now you can take the difference by finding what is 41 square and what is 40 square, but what I will do is, I'll just add 40 and 41 and I tell you 81 is the difference. And you can check it because you already know a method of finding squares of 41 and 40 etc. faster, right? You can do it and you will find it as 81. So what I need to tell you is, basically if you need to find the difference between two consecutive squares, just take the sum. Now here you may feel it as very simple and very easy. You can manually also find, right? So what about 31 square minus 30 square? Just add this two, that is 61. Now why 61? Because 31 square, you know, that is 961 and 30 square is 900. When you take the difference, you are getting 61. But without finding the square, I can take the difference just by adding this. Okay, so similarly here 41 square is 1681 and 40 square is 1600. So the difference you can see as 81. Now here otherwise also you can find, but if I give you questions like 1281 square minus 1280 square. Now can you find the answer? What you need to do? You need to find the square of it. You need to find the square of it, take the difference. But rather what you need to do, just add this 1280 and 1281. Okay, so how will you add? You take twice of 1280 and add 1. That is what this, because I have two 1280s and one extra, right? So 1280 twice, 128 twice, 256. So 1280 twice, 2560. But this one I need to add, so my answer is 2561. So what is 2561? The difference between these two squares, 1281 square minus 1280 square. If you find 2561, how I got it? I just added this two. Very interesting, right? Otherwise what you need to do, I hope you know it clearly now. So don't do all those things. This kind of questions is asked just because there are certain patterns. And if you cannot identify the pattern, don't even try to attempt this question. Just leave this question faster than anyone else. That's the best strategy. Don't try to solve it. Don't see, if you are finding the answer otherwise, you will do this 1281 into 1281. You will find it. Okay, you have 4 steps and final 5 step. Then 1282 into 1282, another 5 steps here to get the answer. After that you need to take the difference and you get the answer. It's not worth. It's not worth. You will definitely get the answer if you are strong in calculation, but other people will get this answer very faster. And if you are taking a CAT paper where normalization and all is there, this is going to be very difficult for you if you are not solving in this way. Now one other important thing which is very simple, the squares of numbers ending in 156 will always end in 156. So squares of numbers ending in 156 will always end in 156. Just keep this property also in your mind. Now if you need to find sum of first n natural numbers squares, okay, so sum of squares of first n natural numbers like this, 1 square plus 2 square plus 3 square plus 4 square etc etc. See, if it is 1 plus 2 plus 3 plus 4 etc, we know sigma n. We know sigma n, and n into n plus 1 by 2 is what? Sigma n. You all know this. And we have also discussed this sigma n square. We can call it as sigma n square. Sum of first n squares, right? So sigma 2 square means 1 square plus 2 square. Sigma 5 square means 1 square, 2 square, 3 square, 4 square, 5 square, like this. So answer is n into n plus 1 into 2n plus 1 divided by 6. The application questions we have already seen like this. you have a 2 into 2 square. This is a 2 into 2 square. So I ask you how many squares are there in this. 1, 2, 3, 4 and the big one 5. So actually this is 1 plus 4, right? Because these 4s and the bigger one, that's what 1 plus 4. And this is nothing but 1 square plus 2 square. And this is nothing but sigma 2 square. And that is nothing but n into n plus 1 into 2n plus 1 by 6. What is n here? Since this is 2 into 2 square, this is sigma 2 square, so n is 2. Let's substitute 2 into 2 plus 1 3 and 2n plus 1 means 5 divided by 6. So 30 divided by 6 means 5, and that's how you got 5. Now all these things you don't want to do in this small case, but if I ask you a bigger case, like how many squares are there in a 5 into 5 square. So in a 5 into 5 square, it will be very difficult for you to visualize or count, right? So how many squares are there in this? It is very difficult for you to count, but actual answer will be 1 square plus 2 square plus 3 square plus 4 square plus 5 square. This is nothing but sigma 5 square. You know the formula. Sigma n square is equal to n into n plus 1 into 2n plus 1 divided by 6. What is your answer? You substitute n is equal to 5. 5 into n plus 1 6. 2n plus 1 means 11 divided by 6. So this 6 and this 6 is getting cancelled out. So your answer is 55. So 55 squares will be there in 5 into 5 square. Or you get questions like how many squares are there in a chessboard. That is nothing but 8 into 8 square. So sigma 8 square. 1 square plus 2 square up to 8 square. So what is your answer? 1 square plus 2 square etc. up to 8 square. You cannot manually find it, but you can apply the formula n into n plus 1 into 2n plus 1 divided by 2. So n is 6, n plus 1 means 9, 2n means 16 plus 1 17 divided by 6. So this is getting cancelled out. 8 into 9 72. 72 divided by 6 means 12. 12 into 17 means 204. So 204 squares are there in a chessboard.